ladies and gentlemen. My name is Þorsteinn. I'm a glaciologist at the Icelandic Met Office, and these are my colleagues and collaborators there. We also work with several other institutes in Iceland and also institutes in the other Nordic countries and elsewhere. And the organizers, since they are Icelanders, they thought it might be an idea to have somebody describe briefly how we do glacier measurements and monitoring and research in Iceland and compare maybe between these two areas, the third pole and the Arctic and Nordic area. This is the Arctic cryosphere, or at least part of it. You can see that the permafrost at different stages takes quite a large space on both sides of the Arctic Ocean. You can see the indications of sea ice there in the Arctic Ocean, and then you can see actually the main glaciated regions. Of course, the huge Greenland ice sheet dominates the scene. There are glaciers in Alaska and northwestern Canada, in Arctic Canada, in the Russian Arctic islands, in the Svalbard archipelago. There are still glaciers left in Norway and Sweden, and Iceland has a sizable population of glaciers, if you can put it in that way. And just as a reminder, most of us are familiar with the figures. If Antarctica melts, sea level will rise 60 meters, Greenland 7 meters. All other glaciers and ice caps in the world combined would raise sea level by 40 centimeters, or close to that. And of those 40 centimeters, 30 centimeters would come from the Arctic glaciers and ice caps outside of the Greenland ice sheet. So that's quite a sizable contribution. This is the current situation in Iceland. And actually, every time one gives a presentation, one has to update the figures on areas because the decline is so fast, and the loss of glacial cover. And these glaciers dominate the scene in the central highlands, which are totally uninhabited and uninhabitable. And they are actually natural wonders. They harbor many interesting natural phenomena like subglacial volcanoes and geothermal areas and stuff like that. They are also an important source of meltwater, glacial meltwater, that is harnessed in hydropower plants in Iceland, renewable energy source. And they are increasingly a playground for tourists. Here are some examples. This is the only glacier that can be seen from the capital, Reykjavik. You can see the areas here, how they have been declining over the past century or so. Here is a graph showing how one of the fronts of this little ice cap has been retreating by 1,000 meters since 1930 until the 70s, advancing again, and after 1995, extremely rapid retreat of nearly all glaciers in Iceland. Data sets like these are in Iceland collected in a collaboration between scientists and people from all walks of life who visit the glacier once a year and record its position and deliver the data to the scientists. This entire data set, going back almost a century, is now available in a new web portal that has recently been opened. Anybody can go in, study the data from the different glaciers and pictures of them and stuff like that. This is a setting here in northern Iceland, which has glaciers that are kind of, in some ways, akin to the Himalayan glaciers, mountain glaciers, small ones, cirque glaciers, and so. There are many of them, and every year, small ones are disappearing in the current climate. This is the largest ice cap in Iceland, the Vatnajökull, one of the three largest ice masses in Europe, with a volume of 3,000 cubic kilometers. If it would melt, it would raise sea level globally by 8 millimeters. So it is a player in this respect. And what is the mass balance doing? Are they, well, obviously they are losing mass, the glaciers in Iceland. Here is a good indicator of the whole situation, the Hofsjökull ice cap. You can see the red columns here. They indicate mass loss. The start of the measurement series is in 1988. It goes to 2022. Out of 35 years, in 5 years there has been mass gain. In 30 years there has been mass loss. The picture is extremely clear and similar to the world picture as a whole for glaciers. There is, though, the period 1995 to 2010 was exceptionally warm in Iceland with very high mass loss. And here you can see the area changes since the end of the 19th century. We hear a lot about these devastating floods that occur in the Himalayas regularly. We have our share of these as well, and we have new dangers coming in regularly because of the glacier retreat. This is a lake that has been forming at the margin here of the Langjökull ice cap over the last 20 years, simply because the glacier retreats from a depression that it has carved, and then the meltwater will occasionally find its way, force its way under the glacier in a tunnel and out down into inhabited areas. So we are monitoring such situations all the time. The flood that is mentioned here in 2020 was a small one. This is only a total discharge of 200 to 300 cubic meters per second. That's a very small event. But actually we have the largest flooding events on the planet occurring sometimes when large subglacial volcanoes erupt under ice. And we are actually waiting for one such big spectacle to come in the next few years. And that is why the Icelandic Met Office and other institutes have installed many hydrometric stations and weather stations and seismometers and webcams and other instrumentation all over Iceland to monitor these dangers of floods from glaciers and other phenomena that occur. Iceland has to deal with many, many natural hazards regularly. What about the future? This paper that came out in Science less than 2 weeks ago has been much in the discussion internationally, and it presents projections until the end of the 21st century, what's going to happen to all the world's glaciers. The data set on the glacier volumes and areas and also scenarios for different regions on climate change and warming and precipitation change are now so good that it is possible to project this for the whole world, really, until the end of the 21st century. You can see some of these figures that have been discussed in media in recent days. What will happen to world's glaciers? You can go into the supplement with this paper and pick out data from every glaciated region in the world, scenarios from different glaciers. And actually, the Icelandic group was quite happy to see that the result for Iceland was similar to results obtained by an Icelandic group about 15 years ago or so, or a little more than that, indicating that this volume change would occur until 2100 and then onwards to 2200, glaciers more or less disappearing, and runoff increasing as a result of that until the middle of this century. 2050-60. And this is something that has been already put into good use so that these changes are not totally devastating. You can also at least intermittently put them to good use. This is the volume decline here until 2200. This is the runoff increase here until 2050 or so. So the National Power Company of Iceland has actually decided to install a new turbine in this power plant here so as to make use of this increased runoff for a few decades to come. This has worked very well. These calculations were actually made within the ranks of a Nordic project named here, and Nordic collaboration has been extremely fruitful for Iceland. We are part of the Nordic family. The Nordic states, Denmark, Norway, Sweden, Finland, and Iceland, and also Greenland along, and Faroe Islands. These are, of course, they have all small populations, 5 to 10 million, which is very small compared with Indian and Chinese standards. And Iceland has only 350,000, so we can only say that international collaboration is extremely fruitful for us. Then there is the International Glaciological Society, which has annual Nordic branch meetings. I don't know whether a Himalayan branch of the International Glaciological Society has been formed yet, but it would definitely be an interesting thing to have. Does it exist?
For branch
IGS, yeah. Yeah.
Every year we organize crash film.
Yeah. Anyway, then the International Arctic Science Committee has been mentioned yesterday. It operates several working groups, including the cryosphere group, which supports workshops, symposia, and sort of facilitates collaboration, runs summer and winter schools. And it has members not only from the Arctic states, but also from observer states. And there are now 2 participants from China and 2 from India on this working group. And just briefly at the end, I want to mention the Global Glacier Watch program that has been in the making by the World Meteorological Organization over the last 15 years or so, sort of information system on the state of the entire cryosphere. There has been in existence for a long time the World Glacier Monitoring Service that sort of collects data on glacier fronts and the glacier mass balance. And then there is the National Snow and Ice Data Center in the US and so, but there was no body that collects data from all components of the cryosphere. So WMO has been working on sort of putting this into effect, and it is coming along where there are already more than 160 stations that have been approved according to certain standards that have to be set before your station is accepted into this. And here is an overview of, well, types of observations at the different stations and also the locations around the world. 22 of these 160-something stations are located in the third pole by now. Only 14 of them are shown here on this map here because some of them may still be in the process of becoming fully confirmed and accepted. But we can see that it is the Chinese that have been really effective in sort of incorporating their sometimes already existing stations into this network here. We are still waiting for actually India to submit a station into this. And just an example here, this is the Tian Shan Glacier Station. You can see what is measured here in terms of cryospheric components. This is the Urumqi Glacier, mass balance of that glacier, mass loss clearly ongoing over decades. This is the Mera Glacier Station in Nepal, operated jointly by France and Nepal. Mass balance work, important site. And here is a mention of 2 stations submitted by Pakistan on these 2 glaciers here. Pakistan, of course, obviously very worried about the situation with the floods that occur and that entirely or partly come from melting of glaciers, along with also meteorological reasons. So this is my summary here at the end. The retreat and mass loss of glaciers in Iceland is well documented. There is general public interest in that and even participation in the monitoring. Glacial runoff in Iceland is projected to increase past the middle of this century. There are opportunities for increased hydropower production associated with that. River courses change and new flood hazards emerge all the time. Nordic, Arctic, and other international collaboration has been extremely fruitful for a small nation like Iceland. And then we are hoping that the Global Cryosphere Watch will become a major player on the scene in terms of delivering data on all cryospheric components. There will be a special data portal operated by this body where people can submit data and people can retrieve data for modeling studies and so on. So thank you very much.